So we'll take more questions and answers on architecture organization in ECE. List out rules for booth recoded multiplier. We start from the lower or least significant bit, and we check each bit one by one from LSB. We change the first one as -1, and we skip all succeeding ones, recording them as zeros, until we see a 0 and change the 0 as 1. This is the booth recorded multiplier. List out the rules for multiplication division of floating point number. First, we'll take the multiplier rule, then we'll go for the divide rule. In the multiplication of floating point number, we add the exponent and subtract 127. See, in a floating point number, we have two parts. First is your exponent, the other is your mantissa. So we add the exponent and subtract 127. Then we multiply the mantissa, second part, and determine the sign of the result. Then we normalize the resulting value if necessary. This is how we multiply it. And for division of floating point numbers, we subtract for multiplication. For division, here multiplication we add the exponent. In the division we subtract the exponent. And then here we subtract, here we add 127. Then in the multiplication we multiply the mantissa. In division we divide the mantissa. And then determine the sign of the result. And we normalize the resulting value if necessary. This is multiplication division of floating point numbers. Define these terms: overflow, underflow. Let us see overflow first. In the single precision, if the number requires an exponent which is greater than plus 127, or if it is not single precision, it is double precision. In a double precision, if the number requires an exponent for it, then the overflow would occur. In underflow, in single precision, if the number requires an exponent which is less than minus 26, or in double precision, if the number requires an exponent less than minus 1022 to represent its normalized form, then the underflow would occur. What is the principle of Booth multiplication? Booth multiplication is nothing but the addition of properly shifted multiplicand patterns. So it is carried out like this. We start with the LSB, check each bit one by one, change the first one as -1, skip all exceeding ones which is recorded them as 0 till you see a 0, and then change this 0 as 1, and then we continue to look for the next one without disturbing the 0, and proceeding these using rules this B and C again. Convert the following binary number into Booth recorded form. So if this is the number 11010, Booth recorded form would be as per discussion. It will be 0 1 1. This is 0 -1 1 -1 0. So 14 Booth recorded form this number. List the two techniques used for speeding up the multiplication process. The two techniques used for speeding, not spelling, but it is speeding up the multiplication process. We have bit pair recording or modified Booth algorithm. The other is carry save addition of summands, or those which are involved in summation. What are the advantages of Booth algorithm? First, it handles both positive and negative multipliers uniformly. Next is it achieves some efficiency in the number of divisions required when the multiplier has a few large blocks of ones. The speed gained, however, by skipping over ones, it depends on the data. So this is not the question, this is the continuity. Right format for floating point in IEEE single precision format. This is the format. You have, if this is the point, the values before it, after it. This is for sign. This is for sign. This is before point, that is decimal. This is after decimal. This is before decimal. This is after decimal. This is the unnormalized version. The value can be represented like this: 0.00100 into 10 to the power 9. This is the normalized version. 2 to the power 6. You can take 3 zeros here. So this is the simple IEEE single precision format. Define n-bit ripple carry adder. N-bit ripple carry adder. A cascaded connection of n full adder blocks can be used to add two numbers or two n-bit numbers. You know that half adder adds two values, 2 values, full adder 3 values. So a cascaded connection of these full adders and full adders that can be employed to use that can be used to add two n-bit numbers. Since the carries must propagate on ripple, because this is a ripple carry adder, through the cascade, the configuration is called the n-bit ripple carry adder. List out the rules for addition and subtraction of floating point numbers. First, we choose the number with the smaller exponent and then shift its mantissa. Write a number of steps equal to the difference in the exponents first of all. Then we set the exponent of the result equal to the larger exponent. Then we perform the addition and subtraction on the mantissa and determine the sign of the result. And then we may normalize the resulting value if necessary. What is memory system? Every computer contains several types of devices to store the instructions and data for its operation. So these storage devices plus the algorithm which implements or implemented by the hardware and software needed to manage the stored information from the memory system of a computer. This is memory system. Give the classification of memory. In memory, you can have CPU register, main memory, secondary memory, and cache. So inside CPU, these registers are memory only. Then you can have cache inside, which is managed by the microprocessor itself. Then outside you can have main memory. We also call it as a RAM. Then outside you have secondary memory, that is a stable storage. Define static memories and dynamic memories. Memories that consist of circuits capable of retaining their state as long as power is applied is known as static memories. In dynamic memories, such cells do not retain their state indefinitely. They needs to be refreshed to do what static memories does. What is read access time? The basic performance measure is the average time to read a fixed amount of information, for example, one word from the memory. So this parameter is called the read access time. Define RAM or random access memory. The storage location can be accessed in any order, and access time is independent of the location being accessed. So access time is independent of the location. This is very important. The memory is termed as random access memory. That is why random, you can access in a memory the data from anywhere. That is random access is there. Next is what is ROM, read-only memory. Memories whose content cannot be altered online, if they can be altered at all, read-only memories. Read-only memories are those memories where once we have written some data, you cannot change it. But there are versions of ROM like EEPROM, etc., where you can actually do it. ROM, see your BIOS, when your computer start or initiates, an operating system is there. Then there has to be some hardware program which should run that may give control of the system to the operating system, because operating system can't do it by itself. And operating system is a software program. So in between you have BIOS that is written in your ROM only. What are pre-ROMs? Programmable ROMs. Semiconductor ROMs whose contents can be changed offline with some difficulties is called pre-ROMs. I should not add these difficulties. It can only be considered as the contents can be changed offline. What is static RAM and dynamic RAM? SRAM and dynamic and DRAM. Static RAM is static. This is static random access memory. So it tends to be faster. They require no refreshing. While dynamic random access memory, the data is stored in the form of charges, so it would require continuous refreshing. What is volatile memory? Volatile. If power is off, data will be gone. So a memory is volatile if the loss of power destroys the stored information. So information can be stored indefinitely in a volatile memory by providing battery backup or other means to maintain the continuous supply of power. What are the categories of memories? You have SRAM, you have DRAM. These are the categories of memory: static RAM and dynamic RAM. What is a flash memory? You will find it in your pen drive, etc. A recent semiconductor technology called the flash memory of a same non-volatility as PROM, but it can be done a bit at a time. So you can program it again and again. It has a life, but life is long. What is cache memory? Memory word are stored in cache data memory, and they are grouped into small packages called the cache blocks or line. So the contents of the cache's data memory are thus occupied of a set of main memory blocks. So cache memory is the area of the memory where recent instructions are being stored so that the CPU does not go to the main memory again and again. It can access it from here. If at any cache fault or cache some data is not found, it can get the data from the main memory, and the things can go on really fast. Mention two system organization for caches. There are two system organization for caches. First is look aside, look through. Look aside and look through. What is rambus memory? Rambus. The key feature of this of rambus technology is this fast signaling method used to transfer information between chips using the narrow bus. Rambus. What is write through protocol? For write operation, it is related to cache memory. So for write operation, the cache location and the main memory location, they are updated simultaneously. Okay, this is write through protocol. Give the difference between the EEPROM, electrically erasable programmable read-only memory, and flash memory. So the primary difference between these two, EEPROM and flash memory, is that flash restricts write to multiple kilobyte block, increasing the memory capacity per chip by reducing the area of control. The difference is the multiple kilobyte block writes. Differences between cache memory and virtual memory. In cache, replacement is primarily controlled by the hardware, by hardware itself. So in virtual memory, what happens? Replacement is primarily controlled by the operating system. Then the number of bits in the address determine the size of the virtual memory. Number of bits in the address, that is the address generated by the CPU. Whereas the cache size is independent of the address size. So this is only one class of cache actually. There is only one class of cache we have. Next is, what are the uses of virtual memory? Virtual memory is the scheme in which what happens, you want to run certain process and they're not able to, you don't have enough space in your main memory to run them. So how to do it? You have to provide a virtual memory, a memory which is not there, but you create a scenario such that process is running in, it can run on the, or can come into the main memory and run through the execution processor, though the area of the memory is not there. So this scheme is virtual memory actually. It is represented or it is implemented by certain ways, demand, paging, etc. For that we use page and frames, etc. So first is protection. Virtual memory, VVM, is often used to protect one program from another in the system. And base and bounds. These methods allow relocation. So user processes cannot be allowed to change these registers, but the OS must be able to do so on a process switch. What is interleaved memory? Banks of memory are often one word wide, so bus width need not be changed to access memory. However, several independent areas of memory can be accessed simultaneously by using the interleaved memory. What is write back protocol? Write back protocol, only if the block in cache is modified. The main memory, when the block must be replaced in the cache. So this requires the use of dirty bit to keep track of the blocks that have been modified. This is write back protocol. So these are a few more questions on your organization and architecture and in the ECE. Thank you so much.